Wakefulness is not controlled only by willpower, motivation, or conscious choice. The body also relies heavily on thermoregulation, the biological management of internal temperature, to help coordinate sleep and waking transitions across the day and night cycle. Core body temperature naturally follows circadian timing patterns that influence alertness, metabolic activity, energy regulation, and sleep readiness throughout the nervous system. Before sleep, the body gradually begins cooling internal temperature to support deeper rest and recovery processes. Before waking, core temperature begins rising again to help increase metabolic activity and physiological readiness for alertness and movement. These temperature shifts function as biological timing signals that help coordinate transitions between sleep and wakefulness across multiple interconnected systems. Wakefulness is therefore partly a thermoregulatory process occurring throughout the body, not simply a conscious decision to wake up. Before sleep begins, the body gradually starts lowering core temperature through thermoregulatory processes connected to circadian timing and sleep initiation. Heat dissipation increases as blood vessels near the skin expand, allowing more internal heat to move outward from the body. This cooling process helps support transitions into deeper stages of sleep by reducing physiological activation and shifting the body toward recovery-oriented states. The nervous system uses these thermal changes as part of its biological timing system for sleep regulation. Cooling is therefore not simply a passive consequence of becoming tired. It is an active physiological process that helps coordinate the transition from wakefulness towards sleep and recovery across multiple systems throughout the body. As core body temperature continues decreasing, the nervous system becomes increasingly able to transition into deeper and more stable sleep states. Lower internal temperature is associated with reduced physiological activation, slower metabolic activity, and changes in autonomic regulation that support recovery-oriented processes throughout the body. This cooling shift helps coordinate transitions away from active wakefulness and toward restorative sleep architecture. Thermoregulatory changes also interact with melatonin release and circadian timing systems involved in sleep regulation. The body is therefore not simply turning off during sleep onset. Multiple biological systems are actively coordinating thermal regulation, metabolic slowing, and recovery preparation to support deeper sleep and physiological restoration across the night cycle. Core body temperature normally continues decreasing across much of the night as part of the body's circadian thermal rhythm. During deeper sleep periods, metabolic demand, physiological activity, and energy expenditure shift into more recovery-oriented states that support tissue repair, restoration, and energy conservation. These overnight temperature changes help coordinate biological processes involved in recovery and long-term physiological maintenance. Thermoregulation remains highly active during sleep because the body continuously balances heat production, heat loss, metabolic regulation, and environmental conditions throughout the night cycle. This means body temperature is not static during sleep. It follows organized biological timing patterns that help regulate sleep depth, recovery processes, and transitions between different stages of sleep and wakefulness. Body temperature is closely connected to alertness because metabolic activity and physiological activation increase as core temperature rises. During waking periods, higher body temperature supports greater energy production, nervous system activity, circulation, and overall readiness for movement and environmental interaction. This thermal rise helps coordinate biological processes associated with attention, reaction speed, physical activity, and cognitive performance across the day. The nervous system therefore uses temperature regulation as part of its broader system for managing wakefulness and activity levels. Changes in core temperature influence how strongly the body shifts between recovery-oriented states and active alertness. Wakefulness is not only psychological awareness. It is also connected to large-scale physiological activation processes coordinated partly through thermoregulation and metabolic timing systems. Before waking occurs, core body temperature gradually begins increasing again as part of the body's circadian wakefulness transition. This thermal rise is associated with increasing metabolic activity, nervous system activation, hormonal coordination, and physiological preparation for movement and environmental interaction. The body is actively shifting from recovery-oriented nighttime processes toward daytime alertness and responsiveness. Cortisol activity, circulation changes, metabolic regulation, and increasing physiological activation all interact with thermoregulatory systems during this transition. Waking up is therefore not a sudden isolated event occurring only in the brain. It is a coordinated biological shift involving multiple systems preparing the body for activity, attention, movement, and cognitive engagement across the upcoming day cycle. Light exposure strongly influences the body's circadian timing systems, including the thermal rhythms connected to sleep and wakefulness regulation. Specialized cells in the eyes detect environmental light and communicate with brain regions involved in circadian coordination, helping regulate timing signals associated with temperature, alertness, hormonal activity, and sleep preparation. Morning light exposure helps reinforce daytime activation patterns and supports the gradual temperature rise associated with wakefulness and metabolic readiness. Reduced light exposure at night helps support cooling processes connected to sleep initiation and recovery states. Artificial light exposure late at night can interfere with these timing systems by delaying thermal shifts and physiological transitions associated with sleep preparation. Thermoregulation therefore interacts closely with environmental light cues to help coordinate biological timing across the sleep-wake cycle. Disrupted sleep can alter the body's normal thermoregulatory rhythms and interfere with the timing systems that help coordinate sleep and wakefulness. Irregular sleep schedules, nighttime light exposure, environmental temperature changes, stress-related activation, and insufficient sleep can all affect how efficiently the body transitions between cooling and warming phases across the circadian cycle. When these thermal rhythms become disrupted, sleep initiation, sleep stability, recovery quality, and daytime alertness may also become less consistent. The body relies on coordinated timing between temperature regulation, metabolic activity, hormonal signaling, and nervous system activation to maintain stable sleep-wake transitions. Sleep disruption therefore affects more than rest alone. It can alter broader biological timing systems involved in recovery, alertness, and physiological regulation across daily life. Wakefulness is regulated through coordinated biological systems that include thermoregulation, circadian timing, metabolic activation, hormonal signaling, nervous system activity, and environmental light processing. Core body temperature continuously changes across the day-night cycle to help coordinate transitions between recovery-oriented sleep states and active daytime alertness. Cooling processes support sleep initiation and deeper recovery states, while rising temperature helps prepare the body for movement, attention, and physiological activation before waking. These thermal rhythms interact with broader biological timing systems that help organize energy use, metabolic readiness, sleep architecture, and cognitive performance across daily life. This changes how wakefulness is understood biologically. Waking up is not simply a conscious decision or an act of willpower. It is also a coordinated thermoregulatory process occurring continuously throughout the body.